Welcome all. Today we are going to see about the testing of solar water heater. So in this experiment we are going to heat the water by using the solar radiation. For this the water heater equipment is required. So that is this. So in which we have the main components of one is solar collecting chamber, which is made up of sheet metal and is covered with fiber plastics. So in which the GI metal has coated with black paint to absorb more amount of solar radiation. In this collection chamber we have copper tubes which have 8 pendings are there, so to circulate the water in these tubes. So why we are using the copper tube means it have high thermal conductivity, so it can conduct so much of amount of heat to water. So for that, first we are going to take water from the source which is connected to this collection chamber. From here the water is entered to this copper tube and collection chamber. While passing through this copper tube, the water gets heated due to conduction of copper and convection of solar radiation in this chamber. So in this we have 3 thermocouples. So to note the temperature of the water inlet at the entrance of copper tube, water at the mid of the copper tube, and the temperature of the water at the exit of the copper tube. So we are going to take these 3 temperatures. Again, from the outlet of the temperature, we are going to connect this to this to the tank, so which are going to store the heated water in this tank. Again we have the thermocouple here, so here also we have the final temperature. To have the heat temperature calculations, we want to calculate the temperature here also. So for every 15 minutes we are going to take 4 temperatures in this inlet of the copper tube, mid of the copper tube, exit of the copper tube, and finally the storage tank. So we are going to conduct the experiment for 1.5 hours. Around we are going to take 6 readings. By using these 6 readings, now we are going to see about the calculations. Okay.
Once we have taken the reading for every 15 minutes, around we have taken 5 different set of readings for interval of 15 minutes. We can see that the ambient temperature is morely common and constant, which is 31.4 degrees Celsius, and around the plate temperature is at the starting point, it is a 31.5 degrees Celsius, which is atmospheric to the conditions. While in the last reading at the 1 hour interval, it is reaches around 49.5 degrees Celsius, which is also the water temperature in the storage tank also similar to the outlet temperature of the solar radiation collection chamber. So these are the readings we have taken for around 1 hour. After that, we have go for the calculation. The first thing we want to find out is heat gained by the water. So we know the formula, we have already studied in the heat transfer, which is a general formula. Q is equal to mcp del T, in which m is equal to mass flow rate in kg per minute. We have measured around it is constant for every time. It is around 6 kg per minute. While converted into per second, it will come 1.6 into 10 power minus 3 kg per second. We know the specific heat of water, which is around 4814 joule per kg Kelvin, and the temperature difference between the storage tank and the ambient temperature at the inlet of the water. So by using this, we have find out the Q. So I have taken the last reading, so which reaches around 114.81 watt. After that, we know that the average solar radiation reaching the water heater around the surface of the water heat is 1300 watt. So from this we can use a efficiency formula to find out the efficiency. So I have taken the last one to find out the efficiency. So the water is gained around 114.8 watt, and the input radiation for the water heater is 1300. So while dividing this, we will get around 11.13 percentage. Like this, we want to calculate the efficiency and water gained by the water for all the taken readings. Thank you.